Hi, welcome to my video on simplify or evaluate exponentials. Simplify each as a single power. Number one, we have the square root of x times the cube root of x divided by the sixth root of x. So the square root of x, we can't multiply these because they're not the same roots. That's a square root, that's a cube root, and that's a sixth root. So we can't multiply or divide. So we have to change them to an exponential. So that's the square root, so that's a 2, understood, and that's a 1, so that's x to the 1/2 times. That's the cube root of x to the 1, so that's x to the 1/3, divided by 6, the sixth root of x to the 1, so that's x to the 1/6. We have all the same bases, so we'll take the base as x, and because we're multiplying, we'll add 1/2, add on 1/3, and we're dividing, so we'll subtract the 1/6, because when you divide, you subtract. And because we're adding and subtracting fractions, we'll get a common denominator for 2, 3, and 6, which is 6. 6 is a common denominator for all fractions. So 2 into 6 goes 3. 3 times 1 is 3. 3 divided into 6 is 2. 2 times 1 is 2. And we got 1/6, same as 1/6. And now because they're all 6's, we can add and subtract them. 5, subtract 1 is 4/6. So that becomes x 4/6 divide 2 cancels out. 2 is a common factor, so it's 2/3. So this expression becomes x to the 2/3 as a single power. Number 2, we have a power of a power, so we're going to multiply the exponents. So 3 cancels into 6 twice, so we get y, so that's a 2. 5x times 2 is 10x, so y to the 10x as a single power. Number 3, we are multiplying on the top. Let's simplify the numerator first. Because we're multiplying, we add the exponents. Same basis as x, so we add 1/8, add on 5/8, and we'll leave the denominator as it is. And so we'll add 1 plus 5 is 6, so that's 6/8. And the bottom stays, and 6/8 becomes 3/4 when you divide 2 into both of them. The 2 is a common factor, and now that's a 1/4. So we have x, because we have the same basis, when we subtract the 1/4, negative 1/4, so we're dividing, we subtract. So that becomes x to the, that's a double negative, becomes a positive. So that's x to the 4/4, which is x to the 1. So that simplifies to x. And number 4, we're multiplying these, so we'll have to make them, we can't multiply them right now because we need the same basis. So 64 is 2 to the 6th. 8 is 1/2 cubed. So changing these, I now have a common base of 2, so we can handle it. So that's 2. So we're going to multiply 6 by x/3. So that's 6 times x/3. Subtract 6 times 1/2. And 1/2 cubed is 2 to the negative 3. So and let's simplify this one. So that's 3 into 6 goes 2, so that's 2x. And 2 into 6 goes 3, so that's a negative 3. And right here, we can write this down. That's 2, so that's 3 times, or we can, let's cancel. 3's cancel, give me negative 1, so that gives me a positive x, and negative 1 times 5 is negative 5. So I cancel the 3's to get negative 1, and negative 1 times x is negative, positive x, negative 1 times 5, negative 5. Now we have the same basis, because we're multiplying, we add, so 2, that's 2x minus 3, add on x minus 5, and 2x add on x is 3x, negative 3 subtract 5 is negative 8. So we have it raised to a single power. Again, in order to multiply these expressions, I need the same basis, so they all convert up to base 2's. Okay, let's look at the next page. That was simplifying. Now we're going to evaluate. Evaluate each. Evaluate each means find the value of. Well, there's two ways to do this one. 8 to the 1/3. We can make 8 2 cubed. And because we have a power of power, we can multiply these, so the 3's cancel, we get 2 to the 1, which is 2. Another way to do that would be to say 1/3 is the cube root of 8 to the 1. The cube root of 8 becomes 2, so that's two ways to do it. Another way, I like to change the inside if I can. Like 1 over 9 becomes 1 over 3 squared. And that becomes 3 to the negative 2 because of 1 over. We have a power of a power. Negative times a negative is a positive. 2 into 2 goes once, so we get 3 to the 1, which is 3. Okay, and right now I have a negative, so that's, we could go 1 over negative 27 to the 1/3 to remove the negative exponent, 1 over. So that becomes 1 over the cube root of negative 27. And so that's 1 over the cube root of a negative 27 is a negative 3, so that becomes a negative 1 over 3. Number 4, 25 to the half. We could go square root of 25, which is 5. That's one way to do it. Another way to do it, 25 is 5 squared. Power of a power, we cancel. 2 times a half, 2's cancel. We get 5 to the 1, which is 5, either or. Number 5, we have an addition. So let's simplify the powers first. So 16 is 2 to the 4. 27 is 3 cubed. So we have to do the exponents first, so we're multiplying, so we cancel, we're multiplying these, so 4's cancel, I get 2 cubed. And again, we're multiplying here, so the 3's cancel, I get 3 squared. So that's an 8 plus a 9, simplifies to 17. 2 cubed is 2 times 2 times 2. 3 squared is 3 times 3 is 9, gives us 17. We have brackets by PEMDAS. We have to do the inside of the brackets first, so I'll leave 125 to the 1/3. 2 cubed is 8 minus 1, 125, and 8 minus 1 is 7, and this is 125 is 5 cubed to the 1/3. 3's cancel because we're multiplying. 3 times 1/3 is a 1, so that's a 5 times 7, and that gives us 35. And number 7, we have the addition and the multiplication. So let's simplify each of these first. Let's simplify the numerator and denominator before I divide. So this is a half. So half is the square root. So I can do the square root of 4. I can go 2 squared to the 1/2 plus 8 is 2 cubed to the 4/3. And because we're multiplying these, we can add the exponents. The bases are the same, 3. So we get 1/2 plus 3/2. Let's continue. And because we're multiplying, the 2's cancel. I get 2 to the 1, which is 2. Because we're multiplying the power of a power, the 3's cancel, and I get 2 to the 4. And because we're adding here, I get 1/2 plus 1/2 plus 3/2 is 4/2. So that becomes 2 plus, we have to do the powers first, so 2 to the 4th power is 16. And that's 3 squared, so that becomes 18. 3 squared is a 9, which ends up to be 2. Works out most times when teachers make up these questions, they will simplify down to a good number. Number 8, we have to work out, let's simplify the brackets first. And let's see, the brackets is 1/4 is 1/2 squared. 16 is 2 to the 4. 1/25 is 1/5 squared. So I simplified each of the, notice we all have base 5s and 2's. So 1/4 is 1/2 squared. That's 2 to the -2. And we're multiplying these powers, so the 4's cancel. I get 2 to the 1. And 1/5 squared is 5 to the -2. And we got a power of a power we multiply, so it's 2 to the 4 minus 2 plus, we're multiplying, negative to negative positive, 2's cancel. So I get 5 cubed. So that gives me 2 to the 4 is 2 times 2 times 2 times 2 is 16 minus 2. 5 cubed is 5 times 5 times 5, which is 125. So 14 plus 125 is 139. It simplifies too. So notice I simplified the brackets here. I simplified to 16 and 1/25 before I worked on the powers. And number 9 here, we're dividing same bases. So we subtract our exponents. So it's x plus 1/4 subtract x minus 3/4. Same basis dividing, we subtract the exponents. So that's 3x plus 1/4. When we subtract, we can add on the opposite, so it's a -x plus 3/4. Or if you think about it, you could put a 1 there. -1 times x is -x. -1 times -3/4, +3/4. And we have 3, and the x's cancel out. So we get 1/4 plus 3/4 is 4/4. So that's 3 to the 1 or 3. So it simplifies to a 3. Notice I wrote subtracting. I put them in brackets, and then I added on the opposite or multiplied by -1. So it works out really well. And the final page. Express the 4th root of 5 times the square root of 3 as a radical in its simplest form. Notice we can't multiply these because they're not the same roots. So let's change them to an exponential. So that's a 1. So that's 5 to the 1/4 times. That's the square root. So that's a 2, and that's a 1. So that's 3 to the 1/2. And if we make them with the same basis, same denominators, that's a 1/4. And a 1/2 is 2/4. So notice now we have the 1/4, we have the 4th root of 5 to the 1 times the 4th root of 3 squared. And so that's the 4th root of 5 times the 4th root of 9. And now, because they're the same roots, I can multiply. So that's the 4th root. 5 9s are 45. So I took the root and I converted it to an exponential to get the same bases on my denominators. That converted to the 4th roots. Because these two denominators are the same, they both convert to the 4th roots. That because they're 4th roots, same roots, I can multiply. Okay. And the last one, without using the calculator, explain why the cube root of 3 is greater than the square root of 2. So the cube root of 3 and the square root of 2. Well, the cube root of 3, that's 3 to the 1/3. And the square root of 2, that's a 2 and that's a 1, that's 2 to the 1/2. Again, if I convert them to the same bases, denominators, the common denominator for 2 and 3 is 6. So 1/3 is 2/6, and a half is 3/6. So I have, this is the 6th root of 3 squared, and this is the 6th root of 2 cubed. So that's the 6th root of 9, and that's the 6th root of 8, and the 6th root of 9 is greater than the 6th root of 8, is explaining how we do it without using a calculator, converting it to a decimal. So that's simplifying and evaluating exponentials using the rules. When you multiply like bases, you add. When you divide like bases in exponentials, you subtract. And the power of a power. And if you like my video, click the like button, the subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.